Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 227, Basic Calculator 2. Let's read the question prompt. Given a string s, which represents an expression, evaluate this expression and return its value. The integer division should truncate to 0, and you may assume that the given expression is always valid. All intermediate results will always be within the range of a 32-bit integer. Note you are not allowed to use any built-in function which evaluates strings as mathematical expressions, such as eval. Let's look at some examples. So we have this string s, which is 3 plus 2 times 2. So obviously we know from order of operations that we should do the multiplication of these 2's first, right? So we would multiply the 2's, we get a 4 here, and now we need to add the 3, so that's how we get the 7 that we need, right? So here in this example, we have s equals 3 divided by 2, and this is really 1.5, but okay, 1.5, but since we're truncating down, it just becomes 1, so that's why we expect 1 as our answer here. And for this problem, it's going to be the same as the first one, where we want to do the division first because that's order of operations. If you don't remember, it's PEMDAS, so parentheses, exponents, multiplication, division, addition, and then subtraction. So we want to do the division first. So 5 divided by 2 is 2.5, but since we're truncating down, it's just 2, and then 2 plus 3 is going to be 5. So that's why we expect 5 as the solution there. So this problem is actually one of the easier basic calculators. Despite being the second question in the series, it's actually the easiest one. It's also a medium question on Leetcode. So before we think about how to solve this, let's think about the most simple case here, which is this, that we have, addition. So say we had, 3 plus 5 plus 7 plus 2, right? In this case, we don't have to worry about any sort of like multiplication or division. All we can do is, we can have our result, it's currently 0. And then when we get to a number, we just add it to whatever the current result is. So now it's 3. Okay, so now we're only adding here, so we're not going to worry about any of these signs. And then we get to the 5, so we can add 5 to whatever the previous result is. So we get 8, and then we get the 7, so this is going to be 15. And then we get to the 2, and then we're going to be at 17. So this is easy because we can simply just take our current number and add it to whatever our previous result was and keep going from left to right. And the same thing is going to be true if we have minuses in here, where this time all we need to do is subtract the current number from the previous result. So that means that we need to keep track of whatever our operation here is. But what happens when we're working with a string like this? Now, what we don't want to do is, parse the string, find all the divisions, do them, and then go through the string again. Ideally, what we want to do is make one pass through our string and evaluate it from left to right. But the issue here is we're going to see things in an order that might not actually be that, order of operations. So for example, if we're going from left to right, our current sum, okay, so we see the 3, so now we have our 3 here. And then we see this 5, and we're going to be like, okay, well, we need to add because the last operation was an add, so we're actually going to get an 8. And then we're going to get to this 2, and now if we divide, because that last operation is a divide, then we'd say 4. But we know that it needs to be 5 because this one needs to happen first. So in this case, what we need to do is we actually need to undo the last operation to fetch whatever value was last there. So what we're going to do is we're actually going to maintain whatever the last number was, and we're going to maintain what the current result is. And the reason that we're going to do this is, we get here and we see that we need to divide. Well, we saw that we can't divide 8 by 2 because we'll get the wrong answer. So what we need to do is to actually undo the, the previous number, the previous operation that we did. So what we need to do is we need to actually take 8 and we need to say, okay, well, we need to get rid of whatever the previous number was. So from 8, the previous number was 3. So we need to get rid of 3. And then we're left with 5. And now we do the division. And we're going to add that back to whatever the previous number was. And now we should get our correct answer. And we're going to do the same thing for, multiplication. We need to undo that last operation. So for example, this one, if we have, let's just erase everything here. If we have, 3 plus 2 times 2. So if we're going from left to right, we're going to see 3 first. So we're going to have 3, and then we're going to see the plus 2. So now we're going to have 5 as our result, and our previous number is going to be 3. And now we see that we have to multiply by 2. Again, if we just multiplied this, we'd get 10, which is not our answer that we expect. So what we need to do is we need to take our current result, which is the 5, remove whatever the previous number was, so it's going to be this 2. And, now we're left with, the previous number was 3, sorry. So that means that we're left with 2. Now we can multiply that number by our current, which is this 2. We get 4, and then we add back the, oops, I don't think you'll actually be able to see that. Then we add back this number here, and then that's how we'll get 7. So this may be a little bit confusing, but what you basically need to understand is that we need to undo an operation every time we see a division or a multiplication, because we're going from left to right and we're taking operations in a greedy manner. So hopefully that makes sense. If it doesn't, when we write the code, I'm going to walk through everything line by line, and it should click in place. It is a little bit hard to visualize, but once you see the code and you can see how we're actually writing it out, it should make a lot more sense. So I'm going to go over to the code editor now, and we can actually write the code line by line, and I'll explain what we're going to do here. So I'll see you there. Okay, back to the code editor, and now it's time to write the code. Remember that we're going to go from left to right through our string here, and we're going to do the operation as we go. So to keep track of where we are, we need an index pointer to keep track of our current index. Also, what we're going to need is we're going to need to keep track of the current number that we're working with. We're going to need to keep track of the previous number that we're working with in the case that we need to undo an operation. Remember that when we have, divisions or multiplications, we need to undo what the previous operation was, so we can parse out that number that we should have been multiplying with. And we're going to need to keep track of our results, which is going to, basically just keep track of our result as we go through the actual processing here. So let's define those variables. We're going to say cur equals prev equals res. It's going to be equal to 0. And we're going to keep track of the current operation, which initially is going to be set to plus. And the reason that we set it to plus is because the first number that we see, going from left to right, we're simply just going to add that to our, current result, which is 0. So like when we see this 3, we would just want to add a 3. So the current number we'd be working with is 3. So hopefully that makes sense on how we set up the problem. Now it's actually time to go through the while loop. So we're going to say while I, less than len s. What we're going to do is we're going to parse out the current character. So we're going to say current character is going to be s of whatever the ith index is. And now there's 3 cases here. We could have a digit, we could have a mathematical operation, or as you can see, we can actually have a white space. So let's handle the case where we have a digit, and do note that it is possible to have more than one digit, right? It could be like 334 plus 32. It's not just guaranteed to be a single digit. So we need to parse out the entire number and not just assume that it's going to be a single digit. Unfortunately, that would make the problem easier, but we can't assume that. So what we're going to do is parse it out. So we're going to say if the current character is digit, we're going to say, okay, we need to parse it. So we're going to say while I is less than the length of string and the current character in s is digit, then what we want to do is we want to parse. So we're going to say cur equals cur times 10 plus integer of whatever the current value is, and then we want to move our I pointer up. At this point, when this while loop breaks, either we're at the end of the string or we have now encountered a digit character in our string. At this point, actually, we need to decrement our I pointer, because let's think about it. So we have the string 334 plus 34. We'll start at the 3, we'll see it's a digit, and then we'll continue parsing. So we'll parse the 3, then we'll parse the second 3, and then we'll parse the 4. And then notice that, this while loop, we'll still go I plus 1, and then we'll end up at the plus, which is the case where this will break, so the while loop will stop. But now our I is still going to be here. And actually in our while loop, we're just going to have a global increment of the I. So we would actually skip over this one when the I gets incremented at the end of the loop. So we actually want to reset it back down to 4 so we can not interfere with that global, I plus 1 at the end of this while loop. You could just do it separately, but to just keep things nice and concise, I like to just have one global, and then I will just decrement it manually here. So that's the reason that we have the I minus equals to 1. Hopefully that makes sense. So from here, what we need to do is we now need to apply whatever the previous operation was, right? So if we parse this 2, we need to apply, whatever the previous operation was to whatever the previous number was, because we've now parsed out the number that we're working with. So we're going to say if cur operation is equal to a plus, then what we want to do is we want to say, okay, we're simply just going to add the current number to our result, and we're going to say that the previous number is now our current number, right? Makes sense. Otherwise, if the current operation is going to be a minus, then instead of adding to the result, we simply just need to subtract the current number from the result, and now our previous is going to be minus cur, right? Because obviously we have a minus here. So now we get into the more complicated cases where we have the actual, geez, I can't type today. We have the actual multiplication. So how do we do this? Well, we remember that we need to undo the previous number. So let's remove it from our operation, from our result, and we're going to undo it by subtracting the previous from the result. And now we're going to add to the result the correct number, which is actually going to be the previous number times what our current number. And then we need to set our previous number equal to whatever the current number is times whatever the previous is to account for that multiplication. So that's going to be how you handle the multiplication case. And the last case for us to do is simply the division. So again, we need to get rid of whatever the previous calculation was because it shouldn't have been applied, because obviously we have not respected the order of operations. So now we need to undo it so we can apply it correctly. So we're going to again subtract from result the previous value, and then we're going to increment result correctly this time, and we're going to say int of prev divided by cur. And the reason that we use int here instead of the integer division is in Python, if you have negative numbers here and you try to use the integer division, it will actually round incorrectly and you're going to get the wrong answer for this problem. So you actually need to use int here on a regular division operator to get it to truncate correctly. Otherwise, like I said, you're going to get the wrong operation. If you don't believe me, you can try it with the, if you get rid of this int and then just do prev divided by cur, but you're not going to get the right answer. So yeah, you need to use int here. Be careful about that. And then again, we're going to say prev is now going to equal to prev divided by cur. So pretty straightforward. And then now that we have processed our number, it is no longer the current number that we're working with. So we simply need to reset it back down to 0. Because now we have processed it. We obviously don't want the next number we see to still have remnants of whatever the last number was, because that number is now going to be housed in prev. So cur needs to be reset back down to 0. Otherwise, you're not going to get the right answer. So now we've handled a case where, it's a number. Remember that there's two other cases. There's going to be a white space case, and there's going to be a mathematical operation case. So what we're going to do is we're going to handle the mathematical operation case, because in the white space case, we don't want to do anything. We just want to increment our I and continue through the string. So we're going to say else if the current character does not equal to a white space, then what we want to do is we want to say the current operation is going to equal to the current character. And that's really all we need to do. We just need to increment our I now, and we're going to continue through the while loop, and essentially this will process out the string and it's going to do all the calculations as we go. And at this stage, all we need to do is simply return res. And let me just make sure I haven't indented this incorrectly. Okay, cool. So if we submit this, we see that our function is going to work and our code will be accepted. So what is the actual time and space complexity here? Well, like I said, we're only going from left to right through our string. So this means our time complexity is going to be big O of n, right? We only have to go through the string one time from left to right. So this is going to depend on the size of the string, which means it's going to be a big O of n runtime. What is the space complexity? Well, we've actually not, used a stack like some other solutions might, and all we've allocated is just constant space, pointers here, for our calculation. So this is actually going to be a constant space solution because we haven't actually defined any extra data structures for this problem. So this is actually going to be your most optimal solution. There is one where you can use a stack, and it is a little bit simpler to write the code for, but your interviewer is most likely going to want you to do it in constant space. So this is definitely going to be the solutions that you want to go with. So definitely one to know. That's how you solve basic calculator 2. Hope you enjoyed this video. If you did, please leave a like, subscribe to my channel, and leave in the comment section below if you'd want to see any other videos. Just let me know the problem number or any topics you want me to cover, just interviewing basics in general, and I'll be happy to get back to you. Just let me know what you want to see, and I'll do my best. Otherwise, have a nice day, and bye.